Hi everybody, and welcome. In today's video we are going to be talking about solving inequalities, graphing inequalities, and looking at systems of inequalities. So the first thing that we need to do is jump into identify what is an inequality. So hopefully it lets me write here. Our first definition is going to be the word inequality, and I'll write down here in a moment once my pencil reconnects. Inequality is a non-equal comparison between two numbers or two expressions. So if we take a look here, it is working, there we go. Again, a non-equal comparison between two numbers or expressions. So if we are taking a look at something like 7 and 4, these are non-equal, so we would write an inequality to help us define what is what. So that right there is a greater than symbol, so 7 is in fact greater than 4. So this is a greater than symbol, and this is a less than symbol. So sometimes having those words next to it help us interpret what it means in context. When we graph inequalities, there's a whole bunch of annotations that we attach to greater and less than symbols. So when we make a line, it is dashed if we use a greater or less than symbol, but it is solid if we use greater than or equal to, or if we use less than or equal to. We shade above for greater because it's bigger, and we shade below for less because it's smaller. That also applies to the or equal to version of it as well. Next, we have to do a little bit of a review of basic graphing. So if you had an equation like this, y equals 2x plus 3, there are two pieces of this equation. The first is your y-intercept, and this tells you where to start. It's always on the y-axis, so it's always up or down. If it's positive, it's up, and if it's negative, it's down. The second piece of information from an equation we have is the slope. So the slope is always a fraction, so if they write it as a number, you can make it a fraction by putting it over the number that's hiding there. The number that's hiding there is 1. And on top, it tells us if we go up or down, and on the bottom, it tells us if we go to the left or to the right. So right is positive, left is negative, up is positive, down is negative. So if we look at this on a graph, we're going to start off at the y-intercept, which is 3. So we're going to go up 3. And it's always on the y-axis, directly on that y-axis. And from this point is where we use the slope. So if it's 2 up, we're going to go up 1, 2. And if it's 1 to the right, we're going to go to the right by 1. So by doing that, we have just made 2 points. We can draw a line through them because it's a linear line. So we have our line. So we started off at our y-axis, and then we went to there, from there to our slope. The tricky thing about inequalities, though, is instead of graphing lines, we're going to be shading. So we're going to either be coloring in above or below it. And the second thing is we're also going to have either dashed or solid lines. So it's not always going to be a straight line that we draw through it, totally connected. Sometimes we just have little dashed regions where we pick up the pencil off the paper as we're drawing that straight line. So on the bottom here, we're going to break it down just like we did in our previous example to our slope and to our starting point, or our y-intercept. So we start off at negative 5, so that means that we go down by 5 to start, and again, always on the y-axis. And secondly, we have a slope of 2, but a slope of 2 is actually 2 over that hiding number, which is 1. So on top is up or down, and on the bottom is left or right. Because they're both positive, it's going to go up and over to the right. So up 2 to the right by 1. Up 2 to the right by 1, up 2, and so on. Secondly, we have to take a look at what our symbol is. So this is just a greater than symbol. So just a greater than symbol is going to mean we're going to be drawing a dashed line. So nice dashed line going through our points. And secondly, just a greater than symbol, the second thing that it tells us is that we are shaded above. So at every point, we just draw an arrow straight up, and that tells us that we are shading above. So here, when we shade this region in, everything above it. And that's how we graph an inequality. For the next one, I'm going to have you take a moment here and identify a few things. So first, what is the slope? So slope here is -3 over 1. So next in words, I'm going to have you tell me, do we go up or down, left or right? So we should go down by 3, and then to the right by 1. Next, I'm going to have you identify where do we start. So we start going up 4 as our y-intercept. Okay, so we start there, up 4, and we said we're going down 3 to the right by 1. So we'll do that a few times, down 3, right 1. Next, I'm going to have you identify, are we dashed or solid? So our greater than or equal to symbol is a solid line. And lastly, are we shaded above or below? So again, greater than or equal to is going to be shaded above. So with all this information, we are ready to graph. We have our solid line, goes through all these points. We are shaded above, so we draw our arrow straight up. And we can basically shade in this entire region that's above it. So that is how we do an example. Flip it over to the back, we are going to take a look at systems of inequalities. And this is when we have two inequalities that share a solution set. So previously, we would have two lines that would cross, and the only thing that they would share would be an individual point. But now, let's say that we have both of these are shaded below. The regions where their shading overlaps. So this is all of the green region. This is all of the blue region. So everywhere that it's double shaded is going to be the solution set. So it's looking like this whole region, all of this overlap that they share is the solution set. So our steps for graphing these and finding where they share the solution set is to first identify the slope and the starting point for both. Next, we need to actually graph those lines and draw arrows to show which direction to shade, but don't shade yet. And then finally, we can shade where the arrows for both lines intersect. So only actually shade when they are coming together. So in this example, we actually shouldn't have shaded these regions here. The only part that we actually want to shade is that black part where they both come together. So for our examples down here, we'll break them down one at a time. So we'll do them in different colors. So this one will be our blue one, and we'll have this one be our red one. So in blue, we start at -3. Our slope is 4, but 4 over 1. So we'll go up 4 and to the right by 1. This is a dashed line, and it is also shaded above. So we'll start off again, -3, up 4 over 1, a dashed line, and we are just shading above it. Second, in red, we start at 3. Our slope is -2, but again, remember it's -2 over 1. And we, let's see here, we are solid. And again, we are shaded above. So start at 3, down 2, and over 1. Nice solid line through all these points. Once more shaded above. And we are looking for the region where these arrows directly come together as our solution set. So where are they both going up at the same time? It's right here. So again, they both have to be coming together. So in black, that shaded area is our shaded region. So as long as you're able to do that today and you can draw those basic graphs and you understand these four things, so the start, the slope, and the shading, and whether it's a dashed or a solid line, if you can do all of that, you're going to be in great shape to be successful in the practice questions today. So you can go ahead and get started on those. As always, if you got questions, let us know, but good luck.